So, Bismillahirrahmanirrahim. So, dear students, today we'll be talking about another important reduction reaction in the carbonyl compounds, which is Clemmensen reduction reaction. ये रिएक्शन भी बहुत इंपॉर्टेंट, इसमें ऑलवेज क्वेश्चन आते हैं आपके एग्जामिनेशन में एंड आल्सो फ्रॉम द कॉम्पिटिटिव एग्जामिनेशन पॉइंट ऑफ व्यू. So let us start. This is what the Clemmensen reduction reaction is. Means जो आपका carbonyl compound है, whether it is aldehyde or ketone, that gets reduced to a hydrocarbon. यहाँ पे आप देख सकते हैं we had this carbonyl in our substrate. यानी जिस compound पे हम reduction reaction करेंगे in the beginning, that's called substrate. इस substrate में we have this carbonyl group. It gets reduced to CH2. This is methylene group. So overall this is a hydrocarbon. So this conversion of carbonyl compound into a hydrocarbon, it is catalyzed by zinc amalgam in presence of concentrated sulfuric acid. This is your Clemmensen reduction. So let us move towards the details. So Clemmensen reduction reaction. Clemmensen reduction is a chemical reaction described as a reduction of ketones. एक चीज यहाँ पे इंपॉर्टेंट आप याद रख लीजिए, दिस रिएक्शन कैन बी यूज्ड फॉर अल्डिहाइड्स एज वेल एज कीटोन्स. लेकिन अल्डिहाइड्स के केस में इट्स नॉट दैट मच यूजफुल, ठीक है, बिकॉज समटाइम्स इट लीड्स टू द फॉर्मेशन ऑफ डिफरेंट टाइप्स ऑफ प्रोडक्ट्स आल्सो. सो वी यूज इट मेनली फॉर द कीटोन्स. दैट्स व्हाई ही राइट्स फॉर द रिडक्शन ऑफ कीटोन्स. And also he writes in the bracket aldehydes. So sometimes we can use it for the aldehydes, but mainly it is used for the reduction of ketones to alkanes. So conversion of ketones to alkanes. जैसे मैंने अभी use किया था word hydrocarbons, which contain only carbon and hydrogen. That's the alkene. Now this reduction is carried with the help of zinc amalgam and concentrated sulfuric acid. So we use zinc amalgam, that is zinc and mercury. This I will discuss after some time. So overall this reaction was named after a Danish chemist, that is the Clemmensen. So it's called as the Clemmensen reduction reaction. So this is the reaction which we have discussed already. Now the point is, what is this zinc amalgam? Zinc amalgam, you might have seen the word, let's say this is zinc, the element zinc. Now this is coated with, let's say this is mercury. So this zinc is coated with a mercury, the piece of zinc is coated with a mercury. So this is your zinc. We know zinc is highly electropositive. It belongs to the transition series, and it gives, since it's highly electropositive, means it will give the electrons easily. So it gives the electrons easily. Any species that can give the electrons, that means now it can act as a reducing agent. So it can give the electrons easily. So we have this coating of mercury here. This is your mercury, Hg. So now in presence of concentrated HCl, hydrochloric acid, we know that in HCl gives H positive ions and chloride ions, and since zinc is highly electropositive, so that means it can, what it can do, that zinc can react with HCl. Highly electropositive elements, what they will react the HCl, they form ZnCl2, they form Zn, zinc chloride, and very importantly it releases hydrogen gas. Now this is important. So zinc is more electropositive than hydrogen, so that it can displace that hydrogen from the halo acids and it can release the hydrogen gas. So जो हाइड्रोजन गैस यहाँ से रिलीज होता है, it slowly moves out of this layer. So that's why once it moves slowly out of this layer, the hydrogen gas which is evolved, so that finally reduces this carbonyl compound. ठीक है? So in general this is a zinc amalgam, means zinc which is coated with the mercury. So it basically releases hydrogen gas and carries the reduction of carbonyl compounds to the hydrocarbons. यहाँ पे आप देख सकते हो, this was our carbonyl group. And now it has got converted to CH2 group. CH2, it's called as methylene in the organic chemistry. CH2, it's called a methylene group. ठीक है? So you can write down this is methylene group. Methylene group CH2. Since we don't have any a carbonyl compound now in the product, we don't have any double bond, so this is a pure hydrocarbon. So conversion of carbonyl, that's your ketone, to hydrocarbon with the help of zinc amalgam and concentrated HCl. Now let's talk about the mechanism portion, which is important. Now our medium contains concentrated HCl, that means H positive, Cl negative. We have zinc present, zinc amalgam, and our substrate is carbonyl. This is our carbonyl. Let's say R1, R2. You can give R1 CH3. If it is CH3, then it becomes a stone, a ketone. Now what happens? We have a lone pair here. So what it does, it donates that lone pair to the H positive, means this oxygen gets protonated. So you can see here, oxygen gets protonated, so oxygen gets a plus charge. Simple. Now we know that oxygen is the highly electronegative after fluorine, highly electronegative element, and highly electronegative elements, they are not stable when they have positive charge. So that they will achieve the stability. Kaise? This pi bond moves towards this to get it stabilized. So when the pi bond moves, this carbon, please look at this arrow, this carbon, it gets plus charge. So that will be attacked by the zinc, which is highly electropositive. So result is that we have this compound where this carbon has now 3 bonds and zinc becomes zinc plus. Now zinc is zinc plus. We have Cl also in the medium, chloride ions are also in the medium, which are there due to the dissociation of HCl. So that chloride ion, now it interacts with the zinc, it forms ZnCl. So after that you will get here, this is our compound OH, and this is ZnCl. Now this oxygen again has 2 lone pairs. So again they will take H plus from the medium. So they form, so what it forms actually, यहाँ पे, I'll just write it here. So it forms OH and then we have a plus charge, and then this is our rest of the compound. This is our ZnCl. Now look at this compound. Now since oxygen is a plus charge, so we know it is unstable. So what it does, it takes this bond away, this bond, to stabilize it. So result is that water molecule is released. यहाँ पे आप देख सकते हैं, he is actually removing this water molecule. यहाँ पे the result क्या बनेगा यहाँ पे? This R1, R2. This carbon has plus charge and this is ZnCl. Now ZnCl, another zinc. Now what it does, it coordinates with the Cl. Zinc metal is present in the medium. So it coordinates the Cl. Meanwhile this Cl, this bond, it moves towards this to stabilize this carbon. So यहाँ पे आप देख सकते हैं. The result is that you will basically have the double bond here. आप इसको यहाँ पे double bond बना सकते हैं. So this is your double bond, ठीक है, with zinc getting a negative charge. Now double bond से क्या होगा? This positive gets eliminated. Now in the next step, this bond moves towards the carbon. Why? यहाँ पे carbon, this carbon zinc bond, it moves towards the carbon because carbon is highly electronegative in comparison to the zinc. The result is that we have a carbon with a negative charge here. So carbon with a negative charge, it's called carbanion. So this is your carbanion intermediate. So in the Clemmensen reaction, one of the intermediates is carbanion intermediate. Remember this. We have a carbon with negative charge, carbanion intermediate. एक चीज आप यहाँ पे important बात ये याद रख लीजिए. There are other mechanisms also which can be proposed for this reaction. For example, one of the mechanisms is which results in the formation of carbene. So that's called carbene mechanism. So those mechanisms have also been proposed for this reaction, but this is the most suitable mechanism which involves intermediate as carbanium. So now carbon has a negative charge and it can easily accept the protons from the medium. You can see from here. So result is that now this carbon has hydrogen atom attached. And zinc is in the form of zinc plus. Now this zinc plus also again it reacts with Cl. It forms zinc Cl and this bond it moves towards this carbon. So result is that we have this species with again a negative charge. That negative charge can be stabilized with the help of this H positive from the medium. Result is that we have a final compound formed where we have carbon attached to the two hydrogen atoms. Means जो यहाँ पे आपका carbonyl था, this one, it has got replaced by CH2 group यहाँ पे. यानी आप इसको ऐसे भी दिखा सकते हो now. This is your R1. This is R2. And this carbon now has two hydrogens. H. And this is another H. So basically now we have methylene group here on this carbon. So conversion of your carbonyl C double bond O into methylene. So what has happened overall that अगर आप एक एंगल से देख लीजिए, now we don't have oxygen in the compound here. So release of oxygen, removal of oxygen, that's also the reduction. Second thing, we have added hydrogen atoms on this carbon. So addition of hydrogen, so that's also the reduction. So in both the cases, this carbonyl compound has got reduced with the help of zinc, mercury and concentrated HCl. This is called as the Clemmensen's reduction. So reduction of carbonyl compounds, in particular ketones, with the help of zinc amalgam, zinc coated with mercury in presence of concentrated sulfuric acid. It results in the formation of hydrocarbons. So this is all about our Clemmensen reduction. This was all about the basics. जहाँ से question आता है competitive exams में या आपके exams में. So you can use that. Now in addition to this, let's go back. So I have attached this PDF also there. So please check the description. A PDF link will be there. And you can download this small note, concise note, and you can use it for the examination purpose. So in addition to this, if also you have any question, so please write down in the group or you can write down in the comments. So inshallah we'll get back. So this is all about today's the small class, and then we'll have one more reaction probably tomorrow. That's the Wolff-Kishner reduction reaction. So thank you. This is all for the day.